pick it up from where we left it. Now, unilag post UTME question number 2, likely examination questions. We are to subtract this from this. We are taking away this from this. That tells you this has a larger value compared to this. Let's go. You have the larger value now, 18630 minus 16418, all in base 9. Let's subtract. Now take note. Normally, arithmetically, you can deduct 8 from 0. It will give you what now? Minus 8. But when dealing with arithmetic under base operations, this is not possible. What then do? You borrow 1 from the digit next to the 0. What do you have? 1 from 3. You left with 2 here. Now that 1 you borrowed has a numerical value that is equivalent to the base under which you're operating. And what base are you operating there now? 9. So the 1 you borrowed has a value of what now? 9. Bring that 9 over, add it to this 0. What do you have? 9. Go ahead, do your operation speedily. 9 minus 8, what do you have there now? 1. 2 minus 1, what do you have there now? 1. Come over here. 6 minus 4, what do you have there? 2. 8 minus 6, what do you have there? 2. 1 minus 1, what do you have there? 0. It's negligible. Your final answer, 2211 base 9. Easy does it. Let's move on to next quickly. Hello students. We are now on the 4th question on series 2. And this question is on the arithmetics of base operations, specifically division under base operation. You have a numerator here and a denominator, and we are expected to carry out this arithmetic process in base 2. What do you do? It's a 3-step process. Let's see. Step 1. You convert the numerator and the denominator from their respective bases to base 10. Let's do that quickly. For the numerator now, you have 1111 in base 2. Now, when converting these from other bases to base 10, what do? You ascribe powers to each of the digits, starting with power 0 on the digits at the extreme right, and the power increases leftward. Let's do that. 0, 1, 2, 3, 4, 5, 6, 7. Let's go now. What do you have? Pick these digits. 1 times the base 2 raised to the power on that particular digit, 7. And you go on like that. Plus 1 times 2 raised to power 6 plus 1 times 2 raised to power 5 plus 1 times 2 raised to power 4 plus 1 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. Now you begin to break them down step by step. 2 raised to power 7 will give you what? 128. Multiply that by 1. What do you have? 128. Let's go on. 2 raised to power 6. That's 64. Multiplied by 1, you have 64. Plus this 32. Plus this is 16. plus this gives you 8 plus this gives you 4 plus this gives you 2. How? 2 raised to the power 1 is 2. Any number raised to the power of 1 will give you that same number multiplied by 1. What do you have? 2. Now finally, you have 2 raised to the power 0. Recollect, any value raised to the power of 0 will give you what? 1. Multiplied by 1, what do you have? 1. Now what do? You add up everything in base 10. That will give you this plus this plus this. Down here, you have 2, 5, 5, base 10. Now we have been able to convert the numerator from base 2 to base 10. Now we do the same to the denominator. Let's do that. Now what do you have for the denominator? 1, 0, 1 in base 2. We want to convert to base 10. Let's do the same thing, ascribing powers. You have 0, 1, 2. Now let's begin to evaluate. You start with this. 1 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. What do you have? 2 raised to the power 2, that will give you 4 times 1, that's 4, plus 2 raised to the power 1 is what? 1 times 0, that's 0, plus 2 raised to the power 0 is what? 1 times 1, 1. By the time you add up everything in base 10, you have 5 to the base of 10. We've been able to carry out step 1. Now, what is step 2? Let's see. After converting to base 10, step 2, you now have to divide normally. You divide normally. You carry out a process of normal division. What do I mean by that? 10 all over 2 will give you 5. That's a normal division. 20 divided by 4 will give you 5. That's a normal division. Take note, in mathematical sciences, every normal arithmetic, like the process of buying and selling, is being done in base 10. Now let's do that. Initially we had 1, 1, 1, 1, 1, 1, 1, 1, all over 101, all in base 2. We converted to base 10. What did we get for the numerator? We have 2, 5, 5, all over 5, all in base 10. Now what do? We carry out a process of normal division. 5 in 25, that will give you 5. Then 5 in 5, that will give you what? 1, all in base 10. We have successfully executed step 2. Remember, I told you, when dealing with division, it's a 3-step process. We are left with the 3rd step. Quickly, let's look at that. Now, quickly, step 3. What's step 3? Recall the base under which you are expected to operate from the original question is base 2. Now we have a result in base 10. What do we do with this? We now have to convert from base 10. From base 10 to the original base. The original base. And in this particular case, on this question, the original base is 2. So let's do that. That means we have to convert 51 in base 10 to a number, let's say x, in base 2. When converting this in base 10 to base 2, what do? You divide. You divide what? 51 by the base you are converting it to. So you divide by 2. 2 in this you have 25, remainder 1. 2 in this you have 12, remainder 1. 2 in this you have 6, remainder 0. 2 in this you have 3, remainder 0. 2 in this you have 1, remainder 1. 2 in this, 2 in 1, you can go. So you say you have 0, remainder what? The value that is here, 1. You have been able to execute substitute all three steps. Now, present your answer, your result, the remainders in an ascending order from down to up. Finally, what will your answer be? 1, 1, 0, 0, 1, 1 in base 2. Easy does it. Quickly, we're going to look at the fifth question you are likely to expect in your exams on Series 2 base operations.